Good evening, my dear students. Today I'm going to start the part 4 class of three-dimensional geometry. Today we're going to see equation of plane. Hope you're following my classes, hope you're taking notes, and hope you're all practicing the sums. Now, here I'm going to start a new topic called plane, which is always considered as a difficult topic when it comes to plane and line combination of questions. So when it comes to 3D, generally a line sum or a plane sum is easy. But when you get combination questions where both line and plane is discussed, then it would be very tricky to solve and students normally leave those in choice. But the problem is, the reason why you have to leave it in choice or have to leave the chapter is mainly because you are sticking to a set of formulas. Don't stick to set of formulas, just learn the formula that is adequate to form the equation and try to change your question to the information that is required to form the equations. Chalo, let's get started with the classes. Now, equation of a plane. In your book, in your syllabus, you have three forms. Equation of a plane in normal form, which is r vector dot n cap equals to d, where n cap is unit normal and d is the distance from the origin. When a point, the next one, equation of a plane, when it passes through a point. So a plane is passing through a given point and it is perpendicular to a given vector. Alright, a plane is passing through a point and it is perpendicular to a given vector. In that case, the vector form is r dot n vector equals a dot n vector. Now, when the plane passes through three non-collinear points, there is also a formula given in the book, but I'm not going for that. I'm going to explain you the concept behind the proof of this formula, the concept behind how this formula is formed, and this is going to be our base for all the sums. So I'm going to help you to solve all the sums with this formula. Well, certain sums I have to take the help of this formula when the question particularly asks me the distance from the origin. Otherwise, most cases, we can pull out all the sums using this one formula. So that is the reason why I am not writing the equation of a plane passing through three non-collinear points formula over here. Now let's start the proof. And I'm going to use your textbook to explain the proof. Yes, here we start. Equation of a plane in a normal form. Consider a plane whose perpendicular distance from the origin is d vector. So as you can see, there is a plane given over here whose distance from the origin is d vector. ON is the normal from the origin to the plane. What is a normal then? Normal is a vector that is perpendicular to a plane. Well, if you consider the plane as the floor of your room, what is the normal? The height of the room. If you consider the wall as a plane, one of the four walls as the plane, the altitude of the wall, that is wall to wall height, that is considered as the normal. So normal is nothing but a perpendicular vector, okay, or the vector of the altitude. Now, ON be the normal from the origin to the plane. N cap is the unit normal along ON. So n cap is along. So n cap is a unit vector along ON. Alright. So that means ON vector will be what? D times of n cap, isn't it? If one vector is lambda times of the other and if lambda is d, then that vector is d times of n cap. Correct? So ON vector is d times of n cap. Now, let's take P as any point in the plane or any arbitrary point in the plane. Okay, so if P is any arbitrary point in the plane, then if I join N and P, what is N? N is the passing through point of the plane. P is also a passing through point, but P is any arbitrary point. Alright, so when I join NP, NP forms a line segment inside the plane and ON forms the normal altitude. Any line segment inside the plane is perpendicular to the altitude. Any line segment formed inside the plane is perpendicular to the normal, that is the altitude. So that means np dot on equals to 0. Correct? np vector dot on vector equals to 0. What is np vector? op vector minus on vector. In dot on vector equal to 0. And what is OP vector? We took it as R vector. And what is ON vector? D times n cap. And what is again ON? D times n cap only. So when you multiply this, R vector dot D times n cap equals to D into n cap n cap. Now D and D will give you 1D only, magnitude, and n cap into n cap is 1. Hence that won't come. So R vector dot n cap equals to D. Again, this D is just a scalar value, so we can exclude it or we can remove it, and then we can take it as R dot n cap equal to D. Okay, the scalar values, we can remove it. As you can see, there are two D's here, one D will get cancelled. So it is up to us to take things into our hand from there. Because it is, if here it is a variable, so you might be confusing. It might be confusing for you. When you do with numbers, you can do it directly because the D over here and the D over here will get cancelled. So only one D will be there. And n cap into n cap will give you 1. So therefore, R dot n cap equals to D. Now the Cartesian form. So R dot n cap equal to D. D is a scalar value. Let us assume n cap is this. And R vector is usually the arbitrary point's position vector. Arbitrary point is x comma y comma z. The position vector of that is x, y, j, z, k. Now what happens when I multiply R vector with n cap equal to D? So xi, yj, zk dot ni, mj, nk equals to D. So cap on top of everything. When you multiply, it becomes xl, mj, my, and nz equals to D. Isn't it? So you get it like this. Instead of doing keeping like this, we can keep it like this also. So ax plus by plus cz equals to D. A, B, C are what? A, B, C are the perpendicular vector, the normal vector. But here it is L-M-N because it is n cap. So Cartesian form of a plane is this. This is how a Cartesian plane of a plane will look like. Okay. Now let's go to the next sums proof. Next concepts proof. There we go. Equation of a plane perpendicular to a given vector and passing through a plane. So just see this diagram. No? There is 3 planes here. All the 3 planes have one perpendicular vector. So it's like a first floor, second floor and a third floor. It's like room in the first floor, second floor and third floor. So there can be only one perpendicular vector for it. But then every plane is unique here because it has a set of points through which it passes through. Isn't it? The perpendicular vector could be the same, but the planes are unique because they uniquely pass through a set of points. Now, how do you find equation of one such plane whose perpendicular vector is given and passing through point is given? So here A is a given passing through point, OA is the position vector of A, N is the perpendicular vector, P is any arbitrary point type because an equation must have an arbitrary point. Only then an equation can be formed. An equation must be in terms of x, y, z. X, y, z is any arbitrary point. So when you join AP vector, you get a line segment. And as I told before, any line segment in the plane is perpendicular to the plane. It's perpendicular to the normal of the plane. So AP dot n vector equals to 0, right? And what is AP? OP minus OA dot n vector equals to 0. Now what is OP? R vector. What is OA? A vector dot n vector equal to 0. So when you open the brackets, you get R dot n vector equals A dot n. So this is considered as one of the best formula to solve all the sums. Keep this in mind, and I'm repeatedly telling you, I'm going to solve all the sum using only this formula. At rare cases, I use the first formula that I've discussed now. Okay, so whenever they ask you for finding equation of a plane, we just need two information. One is a passing through point, two is the perpendicular vector. So whenever they ask you to find the equation of plane, just search for these two info. Now when they ask us to find the equation of line, what do you need? A point and a direction vector. So line means a point and a direction vector, plane means a perpendicular vector and a passing through point. Now I said there was one more case, equation of a plane passing through three non-collinear points. So here the three non-collinear points is R, S and T. So there is a plane which passes through three non-collinear points. Okay, chalo. Now let us take one of the point as the point of reference. My choice, I can take whichever I want. Chalo. I'm going to take this R point as my point of reference. So that means I'm going to look the other 2 points from this point. So direction vector will be like this, isn't it? So RT and RS are two line segments. RB line segment inside the plane. And I told you already that any line segments that is forming inside the plane will be perpendicular to the normal. Normal is the altitude, right? So when there are two line segment or any line segment, inside the plane will be perpendicular to the normal. So that means RT and RS is perpendicular to the normal. So that means using the right hand thumb rule, I can say normal vector is nothing but cross product of RT vector into RS vector. Isn't it? Now I get the normal. I said I need a point and a normal only. Normal I found. Where is the point? Well, R is the point. R is considered as a reference point here. So I'm going to take my A vector in the formula as my OR vector. Fair enough? So this way we come back to the same formula. R vector dot n vector equals A vector dot n vector. So this is the third one wherein you don't have to learn any new formula like this. Okay? Yes. Because many formulas means many confusion. Now let's start with the exercise sums. Okay. Now this time we are going to discuss the questions quickly. Alright? Let's see. First one. In each of the following cases, determine the direction cosine of the normal and the distance from the origin. They want us to discuss the direction cosine of the normal and distance from the... Yes, x plus y plus z equals to 1. This is the vector form of the equation, which is ax plus by plus cz equals to d. This is the Cartesian form. Beg your pardon, this is Cartesian form. Now let's make it into a vector form first. Alright, so r vector, which is gxyz dot n vector, which is I, j and k. Look, X, Y, Z are part of R vector. The coefficient of X, Y, Z are the normal vector equals A dot n vector. And A dot n is what is given as 1 here. So that means this is in the form of R dot n vector equals A dot n vector. But in the question, they want us to find the direction vector. So R vector dot n vector equal to A vector dot n vector. In question, they want us to find the direction cosine and the distance from the origin. So that means we need to convert this into the form of R vector dot n cap equal to D. Right? Chalo. Now let's consider n vector separately, which is I cap plus k cap. Magnitude of this is root 3, isn't it? Now divide both sides by the magnitude. R vector dot I j k caps for all divided by root 3 equals 1 by root 3. Now this is in the form of R vector dot n cap equals to D, wherein the direction cosines will be 1 by root 3, comma 1 by root 3, comma 1 by root 3. And the distance from the origin is also 1 by root 3. Okay, so this is how we do all the sums in the first category. Now, question number 2. Well, if you have a doubt in the first one, it is Z. I'll just give you a brief idea of how to take it. Z equal to 2 meaning it is 0x plus 0y plus 1z equal to 2. So that means it is ax plus by plus ez equal to 0. So r vector dot 0i plus 0j plus k equal to 2. Then it's the same thing. Okay. Now coming to the second question. Find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector. So here the distance is given to us, correct? The normal is given to it but not unit normal, correct? So let us find the cap of this, n cap of this. So that means just find the magnitude of this vector. So r, which will work out to 25 plus 60, 36. Let me write it again. 9 plus 25 plus 36. So this will give us the magnitude of that vector, isn't it? So n vector is vector divided by its magnitude. 25 plus 36, which is 1161, and then plus 9, 70, right? So 3i plus 5j minus 6k by 70 is your n cap. So r vector dot 3i plus 5j minus 6k divided by root 70 equals to 7. Question number 3, where you need to convert the given equation into Cartesian form. That's very easy. Convert r vector to xi plus yj plus zk, because r is an arbitrary points position vector, into I plus j minus k equal to 2. So if you multiply, you get what? X plus y minus 2z equal to 2. Sorry, why 2z, not 2z, just z, because it is zk, so it is just z. Okay, just z. Likewise for the second one, xi into 2y is 2x, yj into 3j is 3y, and zk minus 4k is minus 4z equal to 1. So Cartesian equation. Now when it comes to the third sum, do not be concerned about s minus 2t and all that. As I said before, our vector is xi plus yj plus zk. So we get s times x times s minus 2t plus y times 3 minus t plus z times 2s plus t equals to 50. Got it? So this is how we do the third sum. Now, question number 4. Finding the foot of the perpendicular. Very, very important sum. Okay? Put a star to this question, it is very important. Find the coordinates of the foot of the perpendicular. I'm going to do this C question. X plus y plus z equal to 1 is the equation of a plane is given. They want us to find the foot of the perpendicular here. So where is the foot of the perpendicular? Let us consider a line segment which is from the origin, and they want us to find the foot of the perpendicular. Alright, now let's convert the given equation to the standard form of vector. So as I said already, this is Cartesian form. Ax plus by plus cz equals to 1. I wanted to convert into vector form. So r vector dot I plus j plus k cap equals to 1, which is in the form of r vector dot n vector equals a vector dot n vector. Now we need the foot of the perpendicular. So we need to find the point where the perpendicular meets the plane. Alright. So let us consider, let's know the normal of the plane. The normal of the plane is I cap plus j cap plus k cap. And what is normal basically? A line that is perpendicular to the plane, isn't it? So that means these two lines are parallel to each other, right? Yes. So let's give a name to the foot now. Let's consider foot as n, and let us consider the coordinate of the foot as x1, y1 and z1. Alright. So ON vector will be x1 cap plus y1 cap plus z1 cap. Now, as I said, the normal is a line that is perpendicular to a plane. ON is also perpendicular. So, both the normal and ON are parallel to each other. So, ON will be lambda times of n vector. So, that means x1 I cap plus y1 j cap plus z1 k cap equals to lambda times of I cap plus j cap plus k cap. Now compare the coefficient of I, j, k. You get x1 equals lambda, y1 equals lambda, and z1 equals to lambda. Now the problem here is the perpendicular that is given to us is not any perpendicular but perpendicular from the origin. So that means it comes to the unit normal form, r vector dot n cap equal to d. So just an n vector will not do, I have to do the n cap for this. So if n vector is so and so, n cap will be what? N vector by magnitude of n, isn't it? Magnitude of n, we found it as root 3. So n cap will be I cap plus j cap plus k cap by root 3. We may not be doing this if it was any other point. We are doing this only because it is from the origin. Okay? So now, instead of writing n vector, we are supposed to put n cap here. So all this will have a root 3. Got it? So now we found the foot of the point, the foot of the perpendicular in terms of lambda, lambda comma root 3, lambda comma root 3 and lambda comma root 3. Let me repeat what I did one more time. Plane's equation is given to us. We took the normal from that, and then the normal is actually a normal of the vector that is perpendicular to a plane. But then here they are discussing about the unit normal because the distance is from the origin. So I need to find the n cap, n's magnitude and then n's cap. And the foot I took it as x1 comma y1 comma z1. So on vector will be this. Now on vector will be parallel to n cap. So on will be lambda times of n cap. So we get x1 y1 z1 in terms of lambda. Now the point that we are found out now is a passing through point of the plane. Isn't it? Passes through the plane. So that means I can substitute that in the equation of plane. Equation of the plane is what? X plus y plus z equal to 1, wherein this is the passing through point. Substituting in the place of x, y, z, I get lambda by root 3 plus lambda by root 3 plus lambda by root 3. So 3 lambda by root 3 equals to 1. Root 3 lambda equals to 1. Lambda equals to 1 by root 3. Therefore, the foot becomes lambda by root 3, which is 1 by root 3 by root 3, 1 by 3, comma 1 by 3, comma 1 by 3. Okay, so we took n cap because it's from the origin, otherwise we wouldn't do it. If it was any other point, then we can just manage with O1 vector lambda times n vector. So all the subdivisions of this question will be dealt exactly like this. Let's start with the next question now, fifth one. Find the vector in Cartesian equation of a plane that passes through a point and a normal vector is given. Normal to the plane is what? Perpendicular vector, isn't it? Passing through point is a vector. So this is a vector which is I plus 0j minus 2k and normal vector is this. That's it. Put it in the formula of r vector dot n vector equals a vector dot n vector. Okay. R vector dot n vector equals a vector dot n vector. So let's see what we are getting through that. R vector dot the passing through point, which is 1 comma 0 comma. So I plus 0j minus 2k equals a vector which is I plus 0j minus 2k into this is n vector. I think I mistook the values. So r vector dot I plus j minus k equals, this is r vector dot n vector equals a vector dot n vector, where a is I plus 0j minus 2k into I plus j minus k. Now multiply. So r vector dot I plus j minus k into 1 plus 0 plus 2. So r vector dot I plus j minus k equals 3. This is equation of plane in vector form. Cartesian form, you change r vector to xi plus yj plus zk. So then you get x plus y minus z equals to 3. So this is the Cartesian form. Okay. So that is how we do the next sum also. Now 6.1. Find the equation of the plane that passes through 3 points. Well, consider one as OA, the other one as OB, and the third one as OC. Now consider one of the point as a point of reference. I took A. So find AB vector, which is OB minus OA. Find AC vector, which is OC minus OC minus OA. Then find the normal vector, which is AB vector cross AC vector. Now normal is done. Passing through point is the A point because we took A as a reference point. If B was taken as a reference point, then BA cross BC will be the normal and A vector in the formula will be placed by 0 OB vector. So here I took A as a reference point, so OA vector will be the A vector. Okay. Now, so that's question number 6 for you all. Okay, hope you all understood this. The rest of the things we will do it in the next session.